Hey, True Class, this is a problem from our non-5 homework set, Simple Harmonic Motion. And what we're trying to do is model a mass attached to a spring, pulled from its rest position, and then released. Okay, so if you look at what's happening here, it's pulled down a distance A. This is A. They're telling us the absolute value of A is 3. That's its distance. That's why they're giving us the absolute value. And then it's released. So we start measuring from the moment it's released. So because it is, again, think of this as its rest position, that's like our midline, and then this is the distance the thing is. It's being pulled down to -3 units. It's being pulled down here, and technically it's over here at time. This is time, t equals 0. And it's pulled down and then it's released, so it's going to start going back up, going to come back down, and it's going to keep doing this over and over and over. That's simple harmonic motion. But for it to get all the way back to where it started, that's the period, it's 5 pi seconds. So it started down here, it gets back there at 5 pi seconds. So that's the full period, and the amplitude's -3. So because it's starting with its maximum displacement from rest, that's going to be the cosine. Notice they're giving us two choices down here. So we're going to pick the cosine. All right, the amplitude is 3, so this is either going to be +3 or -3. Because cosine is typically up at positive, the highest number. If it's down here at the negative, the opposite, that's going to be -3. And then the number that's in here, remember that's omega times t. And omega is what we use to divide 2 pi by to get the period. Well, we're dividing 2 pi by omega, and we're getting a period of 5 pi. So do a little algebra, rearrange the omega and the 5 pi, and you get 2 pi over 5 pi equals omega. Alright, the pi's cancel, so omega is just 2/5. Alright, and then 2/5 t, that's our units for seconds there. So that's what's going to go, both of those together in the parentheses. So we're going to select option B. We're going to select -3 there, 2/5 times t. Alright, picking a cosine again because we're displacing initially. We're not starting from rest position. And then we're pulling it downward. Right? It says specifically pull down a distance from its rest position, so that's negative. And then when we let go, time starts. So that means we're starting from a maximum, or in this case a minimum, and just get that inside right to make the period be what it says the period needs to be.